Good morning. I'm gonna demonstrate solving the advent of code question number 5 using Lamdu. Let's see if it works as well that it did yesterday. So let's open the advent of code website and look at the question. I'm not gonna bore you with all of its details. We're gonna, oh wow, this one looks like the parsing is a little bit more involved. So what's going on here? Okay, so we need to parse this drawing of stacks of crates and then how they are rearranged. Yeah. Right. And then we need to output which is in the top. That's cool. So let's start, as always, with copying the example input into a Lamdu REPL. This was yesterday's problem solution. This one looks like it's going to be more involved in the parsing. So do we know how many lines are we expecting? Or I guess we should break it where there's a double new line. And let's turn on the evaluation results. Right. Okay, so I think I'm going to do this with a lot of assumptions. So I'm just going to well, let's first turn this into an array, right? So we have the two parts. I'm extracting it to a let item with command X. I will call it parts. Yes. And let's take the first part and we'll split that by new lines, and we will turn it into an array as well. This will be drawing. All right. So we have a bunch of lines here. And I want to take a slice out of the drawing. So I'm going to, oh, this is a byte slice. Do we have, what's the name for a function taking, well, let's do this. Iterate over it, so from array, but we'll only take its length -1. So open parentheses -1. And we will map then, dot map. Right, let's call this line. And basically what I want to do is take the letters on specific positions. So the first one is going to be at index 1. And I'm going to iterate with steps. And yeah, we're not going to go over the length of the line. So let's use this length to take bytes and give it line, which we need to unpack as a text to get the bytes in it, right? And now I'll map over them, and each one will take it from the byte at from line dot text at this position, right? Which we can call index. Yeah, by the way, if anyone is here, feel free to say hello in the YouTube chat. I should be able to see it. Okay, and we want to see which and then we take this byte and turn it into a character. So it's from ordinal, from code point. And yeah, let's do a wrong step size, for example, 1. And what's going on here? What is the index? First index. Why is this? Oh, sorry. I switched switch the step and the stopping point. Right. So if my steps are 1, then the first character is a space, right? And let's turn it into an array to collect all of them. We see this isn't the right step. So is 2. So is 3. Yeah, 4 looks like the right step here. So yeah, it's nice to have this interactivity. And well, this whole thing, I'll just turn it to an array. And I have an array of the drawing letters, right? And it might not actually be what I want. I think I actually want to transpose it. So I get these as columns, because then we're going to move, I guess, the top of the stack from one to another, right? Move from stack. Let's see. Move 1 from 2 to 1. So yeah. And when it does so, it moves the top of the stack from 2 to 1. Cool. So instead of to array, I'm going to undo and I'm going to choose transpose, right? And then I'm going to do transpose. Yeah, it takes, okay. So it wants a list of lists. So I'm not going to do this to array either, right? And now I'm going to turn it into an array. Of course, it's an array of lists. So first, let's add parentheses dot map and do an to array here as well, right? Now we have the transposed thing. And I suppose we also want to drop these spaces here. So I'll do open parentheses dot drop while. Drop while is the Haskell name. The reason we don't call it drop while, if you open drop, the parameters are named. I suppose we could add like hovers to tell you the name of the variable, because we don't show it. We show it as an operator. If I change it to be verbose, it would show it like this, but no. It's easier to write like this, dot yada yada. So we're dropping the characters that are spaces at the beginning, right? And now we have the columns. So the first column NZ, then DC, M, and then P. Cool. Now, This is going to be the starting state for something. We're going to apply the rules. Let's parse the rules as well. We'll call them our steps. Let's call them steps. Okay, so we take we take parts 1 first of all. Yes, and we split over lines, right? And then what do we do now? We're mapping over that, of course. So we have a line here. And yeah, I guess we can drop the, well, we can split it in words actually, on spaces, text.split, split over spaces. Let's turn this into an array. And actually, we want to take every second item. So actually, it's kind of reminiscent of this here, of like taking items in strides. So let's make a helper function for a sec. I'm going to close this and I'll call it advent5, so I can open it again by typing advent5 here, right? Let's do cars at strides. No, not cars at strides. Items at strides. And yeah, we're going to, you know what, actually maybe it's too silly of a function to make. It's yeah, but still. So now we're going to take every second one. So 1 dot dot length of R1, which are, let's call it words. And we're going to take every second one, and we're going to map over it and take words at num, which we can call index again. Right? And we're going to parse it into a number. And yes, let's make this into an array, to array. Right. So the first one said 1, 2, 1. Now let's make some sense of it. Make a record of amount. You type amount with 1 and M, I suppose. So amount would be, and these would be whatever. Well, I have no good name for it. R1 at 0. But also you don't have to commit in good names in Lamdu. Renaming after the fact, it's only one place in the database. There's no merge conflicts. Yeah. I have a feeling that amount is with 2 M's. Amount. No, it is with 1 M. All right, I guess. Okay, so from from is R1 at 1 and 2, or maybe source and dest. Well, 2 is R1 at 2. And these are the steps. And we will want to fold over the steps, right? Steps that fold. And the initial initial thing will be this one, R0, let's call it initial state. Okay, pressing tab takes me to the next hole, which is here, which is nice. It's the next place where I need to type something. Actually, tab again takes me here, and I will put initial state here. Actually, instead of calling it initial state, let's call it initial. Init. And now what happened is that it's not saying init equals init, it's just this syntax is shorthand for the parameter named init. I'm passing a variable of the same name. Right, so we're just gonna make a new array, I suppose. In the functional programming paradigm, changing arrays in place is not quite a thing. Actually, it can be done in the mutable side of Lamdu, but I think we're going to keep it simple and we don't need to be maximally efficient. So we have this. So we will turn it into something we can iterate on from array, right? It's now a list. And we're going to iterate. No, iterate is the Python function. I'm a bit not as I haven't touched Lamdu in a while. Let's zip these with indices. So I want like a range that starts at 0, 0 dot dot, but like that won't stop anywhere. Yeah. Well, I guess, I don't know if I have it, but let's do 0 iterate num plus 1. This would iterate over indices to infinity. Right. Now we have the row and we have its in this index. And yeah, this thing here is the tail of the zip function, which is for what happens when the lists are not of the same length. So this one is infinite, so I'm just going to end with an empty list once this one is done. And we're going to do this. If RHS, which is the index, equals from, but actually our numbers are 1 based, so let's start with 1 here. If it's equals to from, then we're going to drop 2 items from the array. But let's first handle the situation that we have. Otherwise, if, let's move my face out of the way, the layout changes according to changes I make in the code, so that it fits. We try to make it not to move too much in our layout rules. Okay, otherwise, if RHS equals 2, then there's also something. Okay, this is the first scenario. We're actually going to add to it the items from the from row. So we're going to create an array that is a concatenation of 2 things, of 2 lists. one of them is just going to be the LHS at from array. The other one is going to be, we're going to take the amount, right, from array of from array space, open parentheses, accumulator at, open parentheses. Now, keep in mind that array indices are zero-based. Let's move my face out of the way again. Sorry, cursor on this screen. This. Okay. So accumulator at, open parentheses, from -1. Okay, so the row we are moving to should become, in the first state, DNZ, because it took from DCM, it took the amount, which is 1, I suppose, and it took the, and it added the NZ one, which is the LHS. LHS is NZ. Is that the, yeah, DNZ is the first one. Great. Otherwise, we're going to bring the LHS unchanged, right? And we're at the end, we're going to make an array of it again, right? And now let's iterate over the items. In this case, it's the from. So if you look at this green thing over here, it says which branch was chosen. Also, we see RHS equals from, false. RHS equals to, true, so it took this one. So I'm going to the arrows, I'm pressing right to go to the second invocation of this lambda. And now this is true, this doesn't happen. So there's no value annotation here, right? So, yeah. So now we need to handle this case. So we're going to, again, turn LHS to a list, which we can modify. And I'm going to drop, not this drop, I'm going to use a drop that takes an amount, right? Not the one we used before that dropped characters that are spaces according to a lambda. And I'm going to turn it into an array again, right? So then DNZCMP, yeah, looks like we got the first step right, and the final one should be, actually if we want to check the other steps again, we can not this lambda, I guess, sorry, this one, yeah. If I make the font smaller, and then go to the arrows here. Actually, we need to make it so it doesn't scroll this to the middle because I don't see the annotation. What I can do, however, is if I go here, I don't even have to make the font smaller. We have a key, a command down maybe, command right. Let's open the help. I thought we had, value scope next, alt down, all right. So alt down, and I see, yeah. So first it was made DNZCMP, now it made CM and DNZP, and that's the same CNPs. Oh, are the orders? Oh, I see. I guess it reverses the order of the crates. So the first step, Alt up, DNZ CMP was right. Then afterwards, CM is the same, but DNZP, and then they have CNDP. So something is different in the order of the crates. Crates are moved one at a time. So, okay. So we need to reverse the crates that we are adding, right? So not just take the amount, we also want to reverse this. Okay. So now it's, so the first one, right? The second one, ZNDP, ZNDP. And then the next step, MC, ZNDP, right? And then CM, ZNDP. Okay, that's cool. And then what crate ends up at the top of each stack? So I'm gonna take all of this, all of, okay, I'm going to turn off the annotations because they kind of make things bigger. Okay, I'm gonna take all of this. I'm going to iterate over it. So I'm going to do from array. I'm going to map over it, dot map. And I'm going to take the first item, assuming there is one. What do they do if any is empty? Yeah, they're not saying. Okay. So I'm going to take the first one, and then I'm going to make a string out of it, right? So from characters is the function I have. Now let's turn the evaluation results on again, right? And let's scroll on the bottom. We have CMZ, right? And the answer is CMZ. It's nice. Let's extract it because we're going to switch the inputs, right? So let's extract this out. We call it Advent 5 example input. We have a hole here. Oh no, we don't. But I'm going to add a parameter, call it input tab. I'm going to use input here. Now we can close it and create a new REPL. And I'm just going to call Advent 5 with Advent 5 example input and turn the evaluation results again. The answer is CMZ. Now let's see what they're going to be with my input. Let's create my input. Call it Advent 5 my input. And get my puzzle input, right? Let's copy this, paste it here, close it, and let's RTGWZ, and let's just put it in. RTGWZ THLD. Submit. That's the right answer. Yeah, so this was fun. Let's continue to part 2. So there was mud covering the writing. Okay. It's a different type of crane, and this one picks multiple ones. So I think this is just the bug we had before. Suppose it is, so it's not going to be difficult to change. Let's go back to the example input. Let's go back to the example input and add a parameter called part2. And yeah, it's not running anymore, so it showed us in a gray part what Okay, so here, instead of this reversing, actually, let's do an if. Yeah, let's do an if. So let's extract this to a variable. And let's do here if part 2, then we're just going to put the list. Otherwise, we're going to reverse the list. And this should be all, actually. Part 2 seems easier than part 1. Now, it can't run this because we changed it. Right. Advent 5 example input. Let's first use false and see. Yeah. CMZ was the first result, right? Yeah, we didn't break it. But true, MCD is the answer now. So what happens with Advent 5? My input. Okay, let's see. ST, HG, RZZ, FR. That's right. So this is pretty quick. We're getting more. It looks like it's becoming a Christmas tree, maybe. I don't know. I hope I didn't obstruct the code with my face. So let's review it again when I'm looking at the image again as well. So we parse the input into the two parts, which are separated by 2 new lines. Yeah, I'm not sure if this is a nice way to show 2 new lines. So, you know, we're not limited by escape strings, whatever we can do, whatever we want here. And we just enter 2 new lines, and that's how we showed it. But actually, maybe something like /n in Python, etc., would be easier to look at when you are just reading the code. Yeah, it looks kind of strange. Then we're splitting over new lines in the first part. And then we turn it to an array, and then we basically just did it to drop the last item, actually. And then we took the characters at the right places, transposed it, turn it to an array. Actually, maybe it's easier to see with the annotations, but let's do with a smaller map, not with my input, but we'll use the example input, right? So these are the 2 parts. These are the lines of the drawing, and yeah, and we transposed it and made it into an array, and dropped the spaces, which we got the skips, and actually, I'm kind of missing like what the result was. It's funny. We should have a value annotation for, oh yeah, it's over here at the left-hand side of the let. This is the position of the result. Yeah, maybe when a let is multi-line, it's confusing to put it here. I don't know. But when it's a 1 line, it's a good place to put it. It doesn't take more vertical space. So this was the result of parsing the map. Then we parsed the steps, and I didn't turn it into an array. I just kept it as kind of like a generator because I was going to reduce over it. Did something similar, split it to words, and then took the right ones, turned them to numbers, and turned it into a meaningful array, meaningful record. Then when we fold over the steps, each one, we have it here as a record, and this item parameter gets destructured to the elements of the record. So we can just write, amount and from and to. We don't have to do item dot amount, which is nice. We can also do item dot amount. All right, I can do item dot amount, item dot amount. I opened, yeah. It also works, but when I do it sugars to amount. Yeah, the way syntax sugar in Lamdu works is that it is always applied if it fits the criteria. And as we reduce over this accumulator always changes. That's nice. We can view the results, and we actually tested ourselves this way. It was very useful. Yeah, I think this part was covered pretty in depth. Let's turn off the annotation. Yeah, and then we took the first one, and we then applied from cards to make it into a string. So this was Advent of Code, day number 5. I had fun. Usually I have trouble programming in the morning, but what can I say? I think we actually succeeding in making Lamdu delightful for this. Okay, I'll see you tomorrow at 1800 UTC. Ciao.